All right, let's just jump right in, because today we are going on a mind-bending journey. We're going to connect the dots between some of the biggest ideas out there right now. We're talking cutting-edge AI, the super weird world of quantum physics, and honestly, the deepest question you can ask: what is reality? This is going to be a wild one, so strap in.
I want you to just read that and let it sit there for a second. This is from a cognitive neuroscientist, a guy who studies the physical brain for a living. And he's saying that the actual building blocks of your thoughts, your neurons, they don't even exist unless someone is perceiving them. I mean, what does that even mean? How could that possibly be true?
Well, to get to the bottom of that frankly insane statement, we're not going to start with philosophy. No, our story starts with a very real, very physical, and what seems like an almost impossible problem in the world of technology. And that brings us right to the doorstep of quantum computing. Yeah, we're building these incredible machines that literally run on the fundamental, weird rules of reality itself. But, as you can probably guess, there's a huge catch. You see, quantum computers are just unbelievably powerful, but they're also unbelievably fragile. I mean, just look at these numbers. Right now, they make about one mistake every 1,000 calculations. For them to actually be useful for big problems, we need to get that down to one error per trillion. That's not a small jump. That's a billion times better. It's a massive wall standing between us and a quantum future.
So, how in the world do you solve a problem that big? Well, it turns out you throw another game-changing technology at it: artificial intelligence. Researchers over at DeepMind built this thing called AlphaQubit. It's a neural network specifically trained to be a decoder, to find and stomp out those tiny errors that are crippling these quantum machines.
The easiest way to think about it is like a spell checker. But instead of fixing typos in an email, it's fixing glitches in the code of reality. See, the errors in a quantum computer aren't simple. They're messy and unpredictable. So what they did was train AlphaQubit on thousands and thousands of simulations, and then they fine-tuned it on real data from Google's Sycamore quantum computer. It literally learned to spot these complex error patterns and correct them in real time.
Okay, so let's just say this works. Let's say AI makes quantum computers stable, reliable, and ready to go. What do we do with all that insane power? What are the really big problems we're trying to crack with these things?
Well, believe it or not, one of the biggest goals on the list is to solve one of the oldest and deepest mysteries in all of human history: consciousness itself. And this is where things get really wild. There's a group of researchers who have proposed this incredibly bold, and let's be honest, kind of risky experiment to directly hook up human brains to these powerful quantum computers. Think of it like a cosmic brain handshake. The whole idea is to see if that same quantum weirdness that makes these computers tick is also the secret ingredient that makes us, well, us.
Okay, so this idea that our own minds might be quantum systems, it forces us to ask an even bigger, even weirder question. If our brain is basically a decoder for reality, then what is the nature of the reality it's decoding? Are we actually seeing the world as it truly is? And this is where Donald Hoffman's big idea comes in. He says, look, just think about the desktop on your computer. You see a little blue icon for a document. That icon isn't the real file, right? Of course not. The reality is a dizzying mess of circuits and voltages and magnetic fields inside the machine. The icon is just a super useful, simplified symbol that hides all that complexity, so you can just click it and get your work done.
And this is the punchline. Hoffman says, what if everything we see, physical objects, tables, chairs, the moon, even space and time itself, what if it's all just an interface? What if it's all just a virtual reality headset that evolution gave us? A headset that's not designed to show us the truth, but is actually designed to hide the true, ridiculously complex nature of reality and just give us the simple icons we need to survive.
And look, he's not just spitballing here, he actually uses the mathematics of evolutionary game theory to back this up. And what the math shows is that natural selection doesn't give a darn about organisms that see the truth. It favors organisms that are good at staying alive long enough to have kids. Seeing objective reality is just too slow, it's too expensive, it takes too much energy. So the shocking takeaway is this: the probability that we evolve to see reality as it actually is, in his words, virtually zero.
Okay, I know that is a massive claim. So you have to ask, is there any actual physical proof that something as bizarre as quantum mechanics could be happening inside our heads running the show?
Well, let's look at this amazing study from 2022.
Researchers were using a standard MRI machine, and they found something that just shouldn't be there. They saw these specific signal bursts in the brain, and they were perfectly timed with the patient's heartbeat. But what was truly incredible is that these signals looked just like a known quantum phenomenon called zero quantum coherence. It's basically when a bunch of quantum particles start acting like one single entity. And here's the kicker: as soon as the person fell asleep, the signals vanished. That's a huge clue pointing to a direct link between some kind of quantum effect and being conscious.
So, if this is real, if there are actual quantum processes happening in our conscious minds, we have to follow that thread to its most extreme conclusion. And that line of thinking leads us to, without a doubt, the most speculative and mind-blowing idea of them all.
Now, to get this next part, we need a super quick primer on the many worlds interpretation. It's this idea from a physicist named Hugh Everett way back in the 50s. He basically said that whenever a quantum event has more than one possible outcome, the universe doesn't choose, it splits. All possible outcomes happen, each one branching off into its own brand new parallel universe.
This theory leads to a famous thought experiment, quantum Russian roulette. Picture this. A gun is wired up to a quantum particle. If the particle's spin is measured as down, bang, the gun fires. If it's up, it just clicks. You put the gun to your head and pull the trigger. According to many worlds, the universe splits in two. In one branch, you're dead. In the other, you just hear a click. So here's the question. Which reality do you experience? Well, you can't experience being dead, right? So your stream of consciousness has to, by definition, continue on in the timeline where you survived. From your perspective, you would just keep pulling the trigger and hear click after click after click, surviving against impossible odds and proving, at least to yourself, that many worlds is real.
Now, before we all run out and try this, which you should absolutely not do, it's really important to pump the brakes. The physicist David Deutsch, who's a huge supporter of many worlds, actually argues against this idea of quantum immortality. He says it requires you to make an extra assumption that's not in the physics, the assumption that you can just ignore all the timelines where you die. He thinks that logic is flawed, and his guess is that the assumption is just plain false. So it's a really important reality check on this incredible idea.
So, after all that, where are we? We've gone from AI fixing computers all the way to questioning the fabric of reality and consciousness itself. What we seem to be looking at here isn't just one single discovery, but a huge convergence of different fields that might be painting a radically new picture of the universe.
Let's just pull it all together for a second. We have AI, which is making real quantum computing a possibility. Those quantum computers might be the exact tool we need to finally understand the quantum weirdness in our own brains that creates consciousness. And that consciousness, as Hoffman's theory suggests, might not just be a passive observer of reality, but a fundamental part of what creates the reality we see. You see how each piece builds on the last? It's taking us deeper and deeper.
And all of this leaves us with one final, truly awe-inspiring question. If our awareness isn't just a camera passively recording the world, but is somehow in some way a projector that helps create it, if neurons really don't exist until they are perceived, well, that hands us a profound kind of responsibility, doesn't it? It means we have to ask ourselves, what kind of reality will we choose to create next?